All right, guys, let's talk about molecular formulas now. This is the last part of your set of notes, so please have your note packet open, be ready to take notes. Again, you can always rewind the video to go over things, scrub forward, scrub back, depending on how ambitious you are. Talk with each other, pause, talk with each other to see if you guys understanding, teach each other if you need to, and talk with your instructor if you really don't understand something. Let's get going. So molecular formulas. A formula showing the types and numbers of atoms combined in a single molecule of a molecular compound. These are usually not the simplest whole number ratio. So in a previous lesson, we talked about what an empirical formula is. An empirical formula is the simplest whole number ratio. And I mentioned that empirical formulas are those you find experimentally. In fact, empirical means experimentally. So empirical formulas, we can find the ratios of each atom experimentally, but that doesn't mean we know the actual molecular formula. So what we need to do is work kind of backwards from empirical formulas to figure out what the molecular formula actually is of the compound. And we're going to do that today. Here are the steps to determine the molecular formula. Well, step number 1 says you need to determine the empirical formula. So that's why we learned how to do that first. You can't know a molecular formula unless you first figure out the whole number ratios of the actual empirical formula. Then we're going to determine the molar mass of the empirical formula. Then we're going to divide that molar mass from the molar mass given in a problem. And we'll go ahead and do an example next, so I'll show you that. Then finally, we're going to find the molecular formula by multiplying it by a ratio we found in step 3. So let's go ahead and try this out. Again, I like to just show you how it's done instead of going through the steps. So here's our first example problem. Determine the molecular formula of a compound with an empirical formula of CH and a formula mass of 78.11 grams. All right, so step 1 says to determine the empirical formula. And we are so lucky because this practice problem actually just gave us the empirical formula. Woohoo! That makes it so much easier. We don't actually have to calculate out the empirical formula, though we might have to later on. So remember, you need to know how to calculate the empirical formula. Excuse me. Next, we need to determine the molar mass of the empirical formula. Well, that's easy. All we do to determine the molar mass of the empirical formula is we look at the actual formula. It's made of 1C and 1H. We're going to go to the periodic table and add that 1C to that 1H, those molar masses from the periodic table, to give us the molar mass of the empirical formula. So here it is, 13.02 grams per mole. We're going to hold that off to the side. Next, step 3, it says divide the molar mass given in the problem by the molar mass of the empirical formula. So let's go look up in the problem. It says here we have a formula mass of 78.11. That's the molar mass of the molecular formula. That's the molar mass of the formula we're looking for. Well, that's awesome. We're going to use that molar mass and divide it by the molar mass of the empirical formula. So that's right here. So when we combine those two together, I'm going to take 78.11 grams, that's the molar mass of the molecular formula, divide it by the molar mass of the empirical formula, and that's going to give me this ratio here, 5.99. I'm going to round that up because it needs to be a whole number. It says multiply the empirical formula by a whole number obtained in step 3. That means I need a whole number, so I'm just going to round that up. Again, our rule is 0.9 round up, 0.1 round down, so I'm going to round this up to 6. Now, why is this number useful? Well, I'm going to take my empirical formula and multiply each of the atoms by 6, and that's going to give me my molecular formula. So experimentally I found that the ratio of my atoms was 1 to 1. My actual formula, the actual compound I had in the beaker or whatever I was testing on, was actually C6H6. So that's really cool. Now I know the molecular formula of my compound. Try this one out yourself. This is a second problem. Pause the video, see if you can figure this one out. I challenge you to do so. Did you accept my challenge and pause the video? I sure hope so. Let's go ahead and see if we can figure this one out. So first, it says determine the empirical formula. Unfortunately, this problem makes us do a lot more work. We aren't given the empirical formula. We have to figure it out. We're given these percent composition though. So that makes it a little bit easier. I'm going to go ahead and take these percent compositions and I'm going to follow the steps of figuring out the empirical formula. If you want to know those steps, those were in the last video. But basically, I take those percent compositions, turn them directly into grams right here. Then I find the moles of each of those by multiplying it by 1 over the molar mass. So I'm going to do that for each of those. Then that gives me 2.3 moles of carbon, 4.1 moles of hydrogen, and 2.202 moles of chlorine. Then what it says to do next is to take the smallest mole, so that's this one, chlorine, and divide each of them by the smallest mole. So 2.03 divided by 2.02, that's about 1. Good enough. 4.1 divided by 2.02 is about 2. 2.02 divided by 2.02 is definitely 1. So this gives me a new ratio. This ratio right here is the ratio of our empirical formula. So this is the empirical formula. This is just step 1. It's a 1-to-1 ratio. All right, let's go to step 2 finally. Determine the molar mass of the empirical formula. So here's our empirical formula. Let's find the molar mass of that formula. That's 1 carbon on the periodic table plus 2 hydrogen. So I'm going to take 2 and multiply that by 1.01 for our numbers, for our molar mass of hydrogen. Then I'm going to add that to chlorine, and I only have 1 chlorine, so that's the molar mass of chlorine. That's going to give me a molar mass of 49.48 grams per mole of our CH2Cl. So, sorry, this is not correct right there. I'm going to delete that. That's the molar mass of CH2Cl, so don't worry about that. Next, it says divide the molar mass given in the problem. Oh, hey, we have a molar mass given in the problem. That's right here. Here's our molar mass given in the problem. 98.96, sorry, a little thick, let me erase that, 98.96 grams per mole. Divide that by the molar mass that we figured out of the empirical formula. So let's go ahead and do that. Here's the molecular formula, or at least the ratio. 98.96, that's what was given to us in the problem, divided by 49.48, that's the molar mass of the empirical formula. That gives me about 2, which is the ratio I need. So I'm going to take our empirical formula right here. This is our empirical formula. I'm going to take our empirical formula right here, and I'm going to bring it down, and I'm going to multiply it all by this 2 right here. And that's going to give me a molecular formula. So this is C2H4Cl. This is the actual compound formula, or the molecular formula of the substance I was working on. So that is how to use empirical formulas to find molecular formulas. Lots of steps, but I'm hoping you guys can be able to follow those steps and do that. I'm glad you guys stuck with me. Good luck, guys. Go ahead and do the practice problems, talk with each other, really collaborate, see if you try to get it. You can always rewind this video to go back and see some previous steps. Talk with your instructor if you're not getting anything or if you're having problems. Good luck.